Okay, I've been ignoring this, which is called template specialization for some time. I'll see it in standard library files, maybe like Xhash. Okay, kind of interestingly not in this case. Maybe it's an unordered map. No, the spacing different. No. Anyways, I've seen this before, of course. Um, so what is this? I've just been ignoring it because again, as I said a few minutes ago, it didn't seem extremely important at the time. It's gone over in the New Boston YouTube Bucky's channel on his playlist on C++. So I saw it for the first time like 4 or 5 years ago. But anyways, what is this? So this is an interesting case here. You can already see the error that occurs. Um, hello, hello. Need to hide this little panel. Hello, hello. Still not hidden. Anyways, this little thing over here is just bothering me. Okay, so an interesting case here. We have a template type name T, a function template. Um, so adding two types T, whose names are A and B, could be adding integers, doubles, floats, booleans. I suppose adding booleans. That sounds strange, of course, but adding characters, is that concatenation or is it adding integer decimal ASCII value equivalents, returning a type T? So it behaves as expected for these two cases. We get 5 and 5.3 here as outputs, 5, 5.3. But for 2 and 3, we wonder if it returns the string 2 and 3, or if it does something else like converts 2 to an integer, uh, whatever the character 2 is in an ASCII table, like 90. It's not in the 90s, but whatever it is. Yeah, what does it do? Well, it says cannot add two pointers, and that's because this gets interpreted as const char star pointer to character array, consisting of two characters, in this case, the \0 being the next character, something like that. Okay, so cannot add two pointers. So we have to, so this operator is not defined for pointers, okay, pointers to characters. So instead, and I took this directly from GitHub Copilot's talk from its explanation based on my very vague prompt, which was just meaning of this without any template parameters. Okay, so this example is given. I'm just going to copy it, and up above is the code that I had earlier. All right. So if you use this syntax, and I've yet to run this, we'll see how it goes, but I imagine directly below in the same file, you define a special rule for this data type. So instead of the data type T, whenever you call the function named add and you supply to it two const char pointers like I did down here, 2 and 3, you can, let me do this first. Can say string A equal 2, string B equal 3 here, and probably get this working as long as that operator, the plus symbol, is defined for um, the string data type, which I can't remember. Yeah, of course it's defined, so it'll be concatenation in this case to the string 23, not the number 23, but the string. Okay, but of course that's kind of unpleasant to do sometimes, possibly, and you may not want to waste the space to the 40 bytes in 64-bit debug mode. Okay, so this template specialization business, I didn't mean for this video to be particularly long. So returns this type, constructor pointer. Interestingly, there's a string. It seems a little bit silly, I suppose, but the alternative is actually adding pointers to one another, adding memory addresses. So there's a typecast, or calling the constructor of the string class. So strd up, it's a C function and string duplication. Uh, Interesting. I've seen str cat, I think, but okay. Anyway, so let's see what this does. Won't generate an error. Oh, okay. It's deprecated. Underscore strd. And interesting that that's a warning. An error. Okay. So it's 23 as we saw for the string data types. Anyways, this is some explanation of this template specialization business. Let me query, whoops. Other examples of instances in which template specialization is useful. Performance optimization, sorting, so that's a good example for academia, obviously. Float, T, get inverse, static cast, T, parentheses 1, get inverse. Oh, 1 over value. And a double. And this makes some sense. Pointers. Particularly useful function definition there. Type traits. It's compile time business. And there's hash, which is one instance in which I've seen this before, I believe. Okay, anyways, I'll stop the recording here. I'm sure anybody. Yeah, that's plenty, I'm sure.